So in this lecture, we'll be talking about binary code analysis. So what is binary code analysis? So binary code analysis is often referred to as binary analysis, which is a threat assessment and security assessment framework in a binary level of code. Binary assessment can help development team analyze the raw binaries of an application that comprise a complete complication, which helps to analyze the code security when there is no access of the source code. Also, it is a form of static analysis that does threat assessment and vulnerability testing at the binary code level. So, these analyses look at the raw binaries that compose a complete application. Binary code analysis is usually comprised of a multi-step approach to reverse engineer the binary by attempting to model data types, flows, and control paths using various analysis techniques. Then an attempt is made to analyze the derived model in order to detect recognized security flaws and synthesize the results into detailed vulnerability reports with actionable remediation. Basically, binary code analysis is a typical used to assess potential vulnerabilities in an application introduced in the compilation process. So, to perform an independent security audit of a third-party library without investment of the vendor, or when an analysis is needed but access to source code is not possible for whatever reason. So, why is this binary analysis important? Source code isn't always available for analysis. For example, some companies purchase firmware to integrate with the hardware in their products, and the firmware is in binary format. Another example is software companies that leverage third-party code and libraries such as frameworks, containers, GUIs, and database to augment their proprietary code. And these libraries often contain no source code. Whatever the case may be, it's still important that the consumers of these binary files understand what is inside them. So, binary analysis solution enable organizations to inspect the binary code without any involvement from the vendor to identify the open source component. Then security vulnerabilities, license obligations, and additional sensitive information that could lead to a breach. So let's now talk about the binary code versus byte code. Basically, numbers are stored in a binary form. So the minimum storage unit is a byte. So there are computers with 7-bit and 9-bit I heard, but I never worked with them though. As far as I know, already in the late 60s, the 8-bit on. So here is an example of machine code and representation in assembly language. So the left, as you can see, the numbers are the sequence numbers of the first byte of the command, and in the second column we see the byte of the command. They are written in the octal number system. In the third column, they are assembly language numerics that simplify the human perception of the program. And some commands take up to like 1 byte, and some commands take up to like byte 2 or 3. So in this example, there are no commands that take up to 3, 4 or 5 bytes. In such command also occurs in here. So this is the binary code that is the processor understands. Now about bytecode, the main problem with binary code is its speciality. So two different devices such as laptop and mobile phone have radically different processor and radically different sets of commands and codes. If we want to write a program for them, we need to, I think, write a two separate programs. So traditionally the programs of portability is solved with the help of high level language and compilers. A good compiler is a complex program that takes a long time to develop and is very difficult to maintain. If our compiler supports 5 different architecture, it has 5 different optimizers and code generators. One way to solve the portability and complexity problem is an intermediate virtual machine. It must have a low-level architecture so that it can be easy to implement. On the other hand, it should include the main feature of modern processors, so as not sink in the performance. The virtual processor works the same way as the real one. It sees an array of the number and perceives them as a command to execute. The bytecode looks exactly identical to the binary code. So here is an example of a Java virtual machine bytecode. The only difference between this and this is that binary code is executed by a physical processor and bytecode is a very simple interpreter program. However, as far as I see and know, there are physical processors that can execute the bytecode of a Java machine. So the difference between them may not be quite conditional. So that's all about binary code analysis.